Howdy, everybody. We're back here for day 2 of the Advent of Code. Um, if you want to see what I did for day 1, you can go look at my previous videos. But we're just going to jump right into it again. Hopefully, you're familiar with Advent of Code. But we'll try and do day 2. We're going to start with Rust first, which is a language I'm much more familiar with. And then in the next video, we'll do Haskell, which I am not familiar with. But let's go ahead and read the problem. Okay. If you remember last time, we were thrown in a trebuchet, and it says you're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? Okay, so we got some game we're going to play with the elf. As you walk, the elf shows you a small bag and some cubes, which are either red, green, or blue. Each time you play this game, he'll hide a secret number of cubes of each color in the bag, and your goal is to figure out information about the number of cubes. Interesting. Maybe like a knapsack problem? To get information, once a bag has been loaded with cubes, the elf will reach into the bag, grab a handful of random cubes, and show them to you, and then put them back in the bag. He'll do this a few times per game. Okay, that doesn't sound very knapsack, but we'll see what happens. You play several games and record the information from each game, your puzzle input. Each game is listed with its ID number, like 11 in game 11, followed by a semicolon separated list of subsets of cubes that were revealed from the bag, like red, green, blue. For example, the record of a few games might look like this. Okay, so you have the game, a colon, things separated by semicolons, and like each of the things separated by commas. Each of like the colors in the game. Okay, so there'll definitely be some parsing. In Rust, we can do like some impls for froms to try and parse some of this stuff. In game 1, 3 sets of cubes are revealed from the bag, and then put back again. The first set is 3 blue cubes and 4 red cubes. The second set is 1. Okay, so this is just describing what this looks like. The elf would first like to know which games would have been possible if the bag contained only 12 red, 13 green, and 14 blue cubes. Okay, so some of these are not possible. In the example above, games 1, 2, 5 would be possible. However, game 3 would have been impossible because at one point the elf showed you 20 red cubes at once. So there's only 12 red. Game 3, the first game is 20, so this game would not have been possible. So we're doing some kind of input sanitization, it looks like, actually. Some of these are not valid. Okay, and then it says if you add up the IDs of the games that would have been possible, 1, 2, and 5, you'd get 8. Okay, so we do need the game number because we're going to be adding those together. So we're going to get some puzzle input, and we're going to determine which of the games are valid, and then sum up their game IDs. That doesn't seem too tough. We'll just save the README here. How big is the... There's 100 games, okay. So not a ton. Again, we aren't going to have like a lot of constraints on the complexity because it's not a huge input. So let's just start by parsing these games. I think one thing we can do is create some impls for these. So we'll have a enum color with red, green, and blue. And we'll impl from stir for color. Like that. Easy enough. So now we should be able to, if we ever see red, green, or blue, it will just give us the enum. And then we'll, now we want like an actual round. So we'll have a struct round, which will have a color and a quantity. I guess U32. I usually just like to use U sizes. We'll see if that bites me. A lot of people prefer to use U32, but we'll see. So if we impl from for a round, oh no, this is not a round. This is actually a like a color set. Right, so let's see how did it do this. We split by white space. Yes, the quantity is the first and the color is the next, and it doesn't into which implement, which will work with the from. Okay, so that works. So now we have a color set, and so then we want, now we have a round, which is going to have several color sets, and if we impl from for that, here we want to split by comma, right? So we split by comma and then map that to the color set from and collect them and then just add those. It may be aggressive to use around. We'll see. And then if we do a game, which will have multiple rounds, and impl from, that will give us the, yeah, if we're splitting by semicolon, that will give us these, but it won't account for this first chunk. So let's try and add that. So let's add an ID, and we say like the ID is the, actually we don't want to split by white space. We want to split by colon. And that's close. Iter next, so that's going to get this one, and then this one will be iter next unwrap split. So iter next unwrap parse unwrap is going to give me game plus blah. So before the parse, I actually want to do strip prefix game space, and then I want to parse like that. Okay, this is kind of weird. We can go through them again and look and see if there might be a simpler way to do this. But again, the idea is building up from the top. We have some color, and we impl a from so that we can convert it easily. So when we see red, blue, or green, we can turn it into this enum. The color set is the same. We're going to split by white space, right? So we'll have a white space right here, presumably, and we'll get a 13. And, oh, there will be a space here, so down Well, we'll look at that in a second. So let's just make sure we got this correct. We split by white space for this piece right here. And we get a 13 in a red, so we get the quantity and the color. So for the round, we'll have multiple of them. And we actually want to split by comma. Yeah, I think we want to do by comma space because it has all these spaces, right? So if we split by that, it will get rid of it. So that actually needs to look like this then. And then the game is the same thing. We actually want to split by this, and we want to split by, okay, so those are semicolon. We want to do the same, but with a space. The idea here is it's allowing us to just get rid of these spaces so we don't have an extra white space here at the beginning of it when we do the previous splits. Okay, but we can verify all this stuff. I think it's right. The idea is we're just using the strip and the splits and the impl froms to go from this to what will be an actual structure of a game. So we can verify that here. We'll read from input, and then it's not a double new line. Lines.map game from, and debug the games. Oh, none of these impl debug or derive debug. I thought I did for some of them. Maybe I didn't do it for all of them. This one, I forgot some parens. Self ID rounds. Ayo, okay, there's a lot of them. But let's just look and see. So game 1, 1912. Let's just look at the input for game 1. 19 and 12. And then 19 to 1. And then 13, 11. Okay, that looks right. So it does look like it's doing it right. Okay, so now we have the games. And the question was, let's look at the README. The elf would first like to know which games would have been possible if the bag contained only 12 red cubes, 13 green, and 14 blue. So we're going to have a set, and we want to be able to compare, do like a comparison, where we want to say, is this round less than or equal to the expected round? So we can do that pretty easy. So we'll say let expected, or let max values or whatever equal to a round with a color sets of 12 red. Ooh, I should do this differently, huh? 13 and 14. So the colors is good. The color set, I actually don't think I need, because for a round, you'll only ever have red, blue, or green. So, I don't know why, but for some reason it feels like it should be red, blue, green, but it's red, green, blue, right? RGB. So I actually don't need a color set. And what I want to do instead is, for each round, I'm going to split them. So I'm going to do like let mute start out with a 0, 1, and I'm going to return around. And so I'm going to say colors is equal to split by commas, and then I'm going to map that to splitting by white space. So where did I do that before? Split white space. Oh, it was in the thing. Is it split by white space? I guess is what I think it's just white space. We'll see. I want to have this colors is going to be like a vec of strings. And then I can say, let me think about this for a minute. Is there a better way to do this? Essentially, here's what's going through my mind. Sorry, I get it. I kind of like think in like a weird stacky way as I'm going through this. If I'm going to compare this like set of colors, it would be much easier to do it like this. Right? And then just be able to do an equals thing is like, is it less than or equal to? Because these are all integers, so it's fairly easy to just check. So I want to do the same thing for the round, right? And so the this I actually think I want to make a tuple within this thing. So let's just do it this way. For each color, we're going to split on white space. And the count is that, and the color is color from. Yeah, there we go. It figured it out. I'm wondering if there's like a way to chain that into this, but this looks okay for me. Like the idea being, now I have a red, green, and blue, and I can just do a compare. So I can do this. I'm mostly interested in the ords, because now I can ask if it's less than or equal to. Let's just debug games, the first one. See if it still looks okay. 12, 19. 19, 12, 0, 1, 2, 19, yes, 13, 11. Okay, so it still looks right, but now I can do a comparison of each round, right? So I can say like, let mute sum equals 0, and then we'll just do, I actually probably don't actually have to do this. I can just do like games dot iter dot the for each is a little silly, right? Because I think I just want to do let's do it like this first and see if we can't do it in a method chaining way afterwards. Okay, so we're not interested in this. What we want is like let mute valid equals true. And then right here we just say if valid like that. I think this will work, but I do want to check something. I'm interested in how the orders work. Like if red is less than, but green is greater than, that may not work. So let's actually, I want to go look in the code and see like Rust partial ord. Maybe it's ord that I'm interested in. Oh, you know what we can do? A simpler way to verify this is just do the test input. We can go to the advent of code. We know the solution for this one, so we can test it here. It's not max round, it's maxed values, right? 8 and 8. Okay, so it looks like it does do it right. So if we do it on the regular input, maybe then we solve the problem. 3530. Should we see if we got it? It is not right. It's too high. Turn to day 2. Okay, so oh, I only break the round. How do you do this in Rust? With a thing like this. I guess I can just, I don't even need to check if it's valid, right? Is if I ever get into one of these, I break the game. That's not right. Now I'm getting 0. 4 round and game rounds. If round is greater than max values Break game. Oh, it's not break, it's continue. Is that what I was doing wrong? Yeah. That still gives me 3530, which was the wrong answer, right? That's what I had before. So, okay, so maybe this partial order is not working. So what if I just did impl round 12, 13, 4 is valid. Okay, we can just do that one. If not round dot is valid 2632. Let's see, maybe that's it. I would be interested in impl, maybe what we, oh, okay, that is right. Okay. So it was just it's just the way the order works. So let's go back, because I think we can actually fix that. Let's clean up a little bit. I always like to, like, after you've written a program, read through it again, make sure you like are doing things right. Are there optimizations? Are there simplifications you can do? I don't really actually end up using this color, so I can actually get rid of this, I think, to simplify the code, because I'm putting it in the red, green, blues for the things. So I can just do red, green, blue. Something like that. Yeah. Okay, and let's think about this round then. I mean, this works. This is very simple, and it just says is it's valid. I do really like, especially when I'm writing like packages in Rust, to think about how people will use my code. And so having a partial order or an ordering or an equals, I think is helpful. So I kind of want to read a little bit more into this, just for the rest of this. If you're looking for my solution to it, I think this is largely it. I'll probably do a couple changes to it before I put it up on a gist or something like that. But I do want to just look at that. So let's see if we can't implement an ordering for this in Rust. This, okay, so here we are in ord. When derived on structs, it will produce a lexicographic ordering based on the top bottom declarations. Yeah, see, so why this doesn't work is, think about it as like, instead of, if you treated the colors as like A, B, C or whatever, RGB, if the first one is less than the other one, then it doesn't matter what the other two are. So thinking about that, in that respect, this may actually not be a good use of standard comp ord, because if I was sorting a list of games or a list of rounds, I would actually be interested in reds first, greens. What I'm really asking is, are they is this round valid based on some set of max values? So I wonder if there's some kind of... I wonder if there's something in standard comp that would fit that bill. Maybe people who are more knowledgeable of Rust can chime in here. I would be interested to know. My thinking is Ord is not a good choice for this is valid because it's not strictly an ordering, in the sense that like this is a valid round. And this is an invalid round, right? I would want to label this one as invalid, and this one is valid. But if I were actually doing an ordering of these rounds, it would look like this, right? So I take back what I've said for the last few minutes. I actually think having an is valid function is useful. So maybe we can do like Rust valid type, or how do we it's not a type, it's a trait. Looks like there's this crate that is attempting to do something along those lines. Like what I'm interested in is what I'd actually like to do is have an impl valid. It would look something like that. But as far as I know, there isn't one. Like, right, this isn't gonna... There's no valid scope, so... maybe that crate is what provides it. Okay, so I feel pretty comfortable with this for part 1. Let's move on to part 2. The elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped. However, he can show you how to get the water source to check it out for yourself. It's just up ahead. As you continue your walk, the elf poses a second question. In each game you played, what is the fewest number of cubes of each color that could have been in the bag to make the game possible? Again, consider the example games from earlier. In game 1, the game could have been played with as few as 4 red, 2 green, and 6 blue. That's because it's like the max of each one. So red, red. There's no red in this one. So there needed to be at least 4 red for this one. And here's blue. There needed to be 6 blue for this one. And 2 green. Because green had 2 here and 2 here. Okay, so yeah, so basically what it's saying is if you look at each one, you want to find the largest value of each, right? The largest of each red in each round, the largest of each green, and the largest of each blue. Okay. So we'll do that. And then the power of a set of cubes is equal to the number of red, green, and blue cubes multiplied together. So red had, or game 1 had 4, 2, and 6. So game 1 is 4 times 2 times 6, which is 48. In games 2 through 5, it was 12, 15. Adding up the 5 powers for each game, find the minimum set of cubes that must have been present. What is the power? Notice it says for each game now, not just for each valid game. Because you're checking, now we're checking all the games. Okay, so we're going to build up some power thing. So we can, to solve this, we can add some kind of method or function on the game to get the maximal values and compute its power. So let's do that. So let's impl game and this is not really helpful, but we'll have like let red equal self rounds iter map red max. Just want to get the max for red, green, and blue. And do that. So then part 2 would be the sum of those. Uh-oh, what is it not happy about? Remove these generics. Oh, because I'm using it later, it wants me to borrow it here. Borrow this one as well. Okay. This is just another Rust thing if you're not familiar with Rust. Using games here kind of takes ownership of it, and so if I want to use it down here, I need to instead borrow here. Okay, but that doesn't seem too hard. Basically, I look for the max of the reds, greens, and blues, and then multiply them together, and then add up all those. 69, 629. We got it. Okay, there is day 2 in Rust. Not too shabby. Maybe I'll just do one more pass in the code, see what it looks like, and then we'll call this a day. Where are we at? 38 minutes. So we got some. I mean, if anyone's actually ever watching this stuff, we can continue reading. These are pretty standard. This for loop. Now that I have it is valid, I can either return, if it is valid, I either return 0 or the game ID. So I could actually do something like this. Let sum equal games dot. Okay, it figured it out for me. So we want to filter on where all the rounds are valid. Like, I actually don't think... Okay, we can just do... Oh, no, I can't do that. Sometimes you can simplify this, if like right here where I map the round. from. I can't do that here because I'm calling a method on it. So is that faster than, or is that cleaner looking than this? I don't know. Maybe that's up to the viewer. This looks pretty clear. It probably will seem, it probably looks better when it's like that, right? So we iter, filter, only on the rounds where all are valid, and we map by the game ID, and we sum those up. Okay, yeah, that one feels good too. So the only, I mean, these two look pretty simple. Then the question would be, could any of this parsing be made simple? I know some people like to use regular expressions. We know the regular expression would always match. So the question is using the regular expression better or not? I mean, we do have a lot of unwraps here. We do have a lot of parses. You still are going to have to parse and unwrap, though, when you're using the regular expression, right? So you do something like, I won't actually do it, but we'd say like re.match, and it would be on something like that. And then you would do what? You'd do like, yeah, so you'd still do parse unwrap, and then you'd still find this color, and you'd still do the match. So does that look any better than this right here? I don't know, probably not. I'd be interested in your opinions if you think it's not. Let's call this polls, though. Isn't that what he did in the thing? Actually, it is colors, so maybe we'll just call it colors still. It's a little funky because we have this color here that kind of shadows this after we get through it. Count color. Okay. That feels okay, I guess. I hope you guys get an understanding of, like, for most like real programming, I don't know, maybe I don't have a similar experience as everyone else, but it's sometimes you just have to get the work done, and you just have to, you know, pound it out and submit it and hope it, you know, it passes everything. But most of the time it's collaborating, thinking through. It's very iterative process, right? Where you're saying, oh, I'm going to make changes to this, modify it. That's not uncommon, and I think it's fun to kind of do that when you're doing these challenges, because that's what happens in real life, right? So if you're practicing these for a job interview, or you're practicing these to keep your skills sharp, they want to see that iterative approach, right? Like, the simplest solution is often, well, let's just try solving it with brute force, which these ones haven't had any like complex algorithms we've had to find or discover through analysis. And just to clarify, there may be times when I won't know the answer and we'll have to start Googling, right? So it's okay to like go through that iterative process. The interviewers and people, when I do interviews, that's what I like to see, right? Is I want to see someone who's like, oh, well, let's just start with this and see where we can go. I personally could always do better of taking my thoughts to words. Sometimes you'll hear me rambling, or I'll start on a subject, but then it will bring me to another subject. I kind of work in a stack-like fashion in that respect, where I'll like dive through the stack and then come back up to the point that I was at before. so it can sound a little confusing. I apologize for that. But anyway, here you go. I think this is a pretty good example of the solution in Rust. Yeah, you could probably clean up some of this stuff. But it feels pretty good to me, so I'll stop the recording right here. And in a few minutes, we will try and solve it in Haskell in my next video. Hopefully, it won't be as hard. Fortunately, these are very iterative solutions. Or sorry, functional style solutions. So I think that will translate well to Haskell, but we'll see. Talk to you later.